Hello everyone and welcome to Math Entrance Test 11 Plus. I'm going to consider numerical section in test number 1. So that's simply working with numbers, with numerical expressions, how to simplify, how to expand the brackets, and also working with percentages. Alright, so if you want to develop the proper skills in order to get the school of your dream like Sevenoaks, Kings, probably Broomsgrove, okay, that's right for you. So first I want to show you the typical problems that we're gonna go through. So you fix them. First try to do by your own, and then let's have a look and compare it with my explanations. Alright, so that's their typical problems. Again, pause the video, try to do by your own, and let's get started. In case you want to see how it's better to work out, just watch the section video dedicated to specific problem. If you're ready, if you accomplished, let's get compared and let's have a look at my explanations. Alright, so fill in the blank space in order to make calculations correct. So what does it mean? That means we need to put a specific number so that it makes your equality actually correct. Okay, so the way I'd like to consider is simply, let's discuss that you have 14 and you have 7. So definitely you can represent your 14 as 7 times 2. So what it means that you have 7, you have 7 on the right side. So that means here is 8 and here is something, so that together with 2, they need to arrange 8. So obviously this is 4. So that's why 14 times 4, and 4 is the base number. If you like, you can just check it, how it works. And 7 times 8 is going to be 56. So 4 times 14 is going to be also 56. So that's 56 on the right side. But I don't recommend to check because that's the waste of time, and to show you for clearness that it works properly. Alright, so let's get to the next one. So 65 and 10. Alright, so we've got 65, so that's why it's definitely 5 and 65. So we're thinking about what to multiply 5 in order to get 65 is going to be 13. Alright, so 13 times 5, that's how it looks like. But we have 10, so 10 comprised 5 and 2, so 2 and 5. So that's why we can decompose 12 as 2 by 6, okay? So we're still multiplying. So this is 12 and this is 65. Okay, now we've got that we have 2 and 5, which is 2 and 5 on the right side. So that's why the missing number is 6 times 13, okay? 6 times 13, and that's the missing number. Okay, so let's multiply. So we'll get 60 and 18, okay? 78, that's the missing number. If you want, you can check it by using calculator, but this is not calculator section, and the total result should be 780, okay? So next one, 36 by 8 is equal to 4 times something. All right, that's much easier because 8 is 2 times 4. That means you have 4 and 4, both sides. So that's why 36 times 2 will be the missing number, okay? So that's the best way. I don't recommend, so many students using, for example, I show for this case. So the result, the missing number here is 72, okay? So the missing number is 72. And I just highlight all results here, okay? Oops, that was 4. The missing number is 4. Here is 78 and here is 72. So many students used to work out like this. So let's pretend we're solving the last one. 38 times 8 equals 4 times, let's say, unknown x, and they're trying to find x. So this is also the way, but maybe it will work a bit different. And on top of that, this is sort of, you need to solve like an equation, okay? But that's not what I was supposed to do. So this is also legible. If you can work it out pretty fast, you can use this way. But I recommend using, the decomposition by factors or breakdown by factors so that it's really easy to spot. Okay, so 38 over 4 is 2, and that's why 38 times 2 is going to be 72 as well. So that's an alternative way. So you can use alternative way through using equation, basically using equations, but I don't recommend one more time. Okay, let's move next. Which number is 25% of 160? Okay, so let's go back to 25%. What percentage is? It's simply the fraction 25 over 100. Okay, but you need to simplify this fraction as much as you can. So in other words, you need to present your fraction in the simplest form. So 100 is 4 times 25, okay? 4 times 25, and 25 can be cancelled on top. So that's why it's simply 1/4. And now, because you applying this fractional share out of 160, simply doing the following. You apply this share to 160. In other words, you dividing 160 by 4 equal parts and taking 1. If you like, just go by definition, what fraction is. Okay, so that's going to be 40, and the 40 is going to be the final result for this. Okay, so let's move next. 22 out of 150. In this case, it's not really convenient to use this approach. Why? Because it seems to me that 22 over 100. Yes, so actually you can apply and try to cancel 150 and 100. So 150 is simply 15 times 10. 100 is 10 times 10, okay? So 1/10 cancel off, and 15 and 10 also can be cancelled because 22, you can grab 2 from there and leave 11 times 2. 15 is 5 times 3, so that's why you can cancel actually. Okay, and so here is 10, which can be completely cancelled with the bottom 10, and you're left with 33. Okay, but I'll show you a bit different way using percentages. So sometimes it might work when you use mental math. So let's have a look. 22% of 150. First, it's reasonably, what if you calculate 10% first? So 10% is 1/10 out of your number 150. Okay, so 10th part of 150 is simply 15. So you've got 15. But you have 22%. That means you have actually 20%, which is twice more than the result of 15, okay? And on top of that, you'll need to add 2%, all right? Which is 10 times less than your 20, okay? If your 20 is 15 times 2, which means it's 30, so 2% is 10 times less, so that's why it is simply 3. So 10 times less than 20%, which corresponds to 30. So that's why finally you can get 33 in the same way. So that's more about mental math and more about mental calculations of percentages. All right, so choose any track that you are confident with, okay? So let's move next. And finally, let's set up the results here, okay? Let's move next. So here you need to work out working with decimals and divide by a number and give you answer as the fraction in the simplest form. So what does mean fraction in simplest form? For example, you have 4 over 16, but an equivalent fraction, which is the simplest one, is the fraction that you can't cancel anymore. So that's why 4 over 16 is simply 1 over 4, because you can cancel the top and the bottom by 4. So that's why 1 over 4 is the simplest form. So that simplest form of the fraction, okay? So that's why here you just simply need to work out the preference of operations. So first, work out expression in brackets. So 2.3 and 7.7 is going to be 10, obviously. and then you divide by 15, but I would like to put as the fraction. Now you have the fraction, which is not in simplest form, so you're going to cancel that. So 10 is 2 times 5, while 15 is 3 times 5. So both 5 will be cancelled, leaving you with 2 over 3, and this is the final result in their simplest form, okay? Hope you did the same. Let's move next. So work out the following showing your workings. All right, so 125 times 250. So, okay, I'll show you. So you know that you can use the call methods, okay? But I'll show you how to do it in a bit different way. So 125, okay, what I'm going to do with that, I'm going to write that this is 125, and I multiply by first 200, okay, and then by 50. So what I'm going to do, I'm taking 2 multiplied by 125, and I'll get 250, okay, and on top of that I adding those 2 zeros, okay, it's going to be 25,000, all right. So next I'm going to multiply 125 by 50. So I simply multiply in this way, like using simple expansion, okay? So 125 by 50, I multiply by 5, and then I add 0. So in other words, I multiply first by 10, okay? I had 25, that's the original, okay? 25,000, and on top of that, if I multiply that, I'll get 5 by 100. The 6 is 500, and 5 by 25 is going to be 125, so it's going to be 625 in total. And because I'm multiplying by 10, so I just simply add 0. So on top of that, I simply add in 6,250. So that's I'll show you how to do without column methods. But if you are confident with column method, and I think that works pretty fast as well, so use the column method, okay? So I'll get 31,250 as the final result for the first. All right, let's move next. So you need to calculate a quarter of $640. So what does it mean, quarter? Quarter means a fraction 1/4. In other words, that's 25%, right? Because 25% converted into a decimal will give you a fraction 1/4. So you multiplying by $640. That's how normally you calculate the share of something or a fraction of something. Okay, so in other words, you need to 64 times 10 divided by 4. Okay, so the way I do 64 by 4 is simply, it can be cancelled because 64 is 32. Okay, it's 8 times 8. Using the times table is better, I think, than times 10 and over 4. And 8 and 4 will be cancelled, leaving you 2 here. So if I cross out, you'll get 2 here, and that's why you'll get 2 times 8, 16, and 160 then. Okay, so that's going to be 160. Or again, you can divide using the column methods, no problem. So next one, okay, 1,700 you divide by 34. What I'm going to do, I'm going to write as the fraction, because I definitely know that if I split 1,700 into 17 times 100 and over 34, I will definitely get the following. So 17 and 34 can be cancelled, leaving you 2 in the bottom and 100 on top, because 34 is simply 2 times 17, okay? And 17 will be crossed out. And now you're left with 100 over 2, which is 50. So that's the way how you can do without the column methods. All right. So next one. Multiplying the fraction. How we multiplying the fraction? So we've got 3 over 4, and we times 16 over 27. So we're writing the following. We put the one single line, and then we start multiplying 3 by 16 and 4 by 27. But I don't recommend to multiply and then trying to cancel. I first recommend to cancel, and that's an idea. So 3 and 27 will be canceled, leaving you 9 in the bottom part, okay? What about 16 and 4? 16 and 4 can be completely cancelled, leaving you 4 on top. So that's why the fraction is 4 over 9, okay? So that's the simplest form of your result or your product. So make sure you cancel them first, and only then you trying to multiply. But there is nothing left to multiply. Okay, so how to add fractions? So that's the result. So how to add fractions? We need to do the following. So we need to do the following. We need to look for a common denominator. I'll show you how you can do it in two ways. So the first one is pretty straightforward, but in this case you need to work with bigger numbers. So what I'm going to do, the common denominator is simply multiplication 15 and 20. Okay, and then what I'm going to do, I'm going to say that, okay, so this 20 goes crisscross and becomes the extra factor for 2. So that's why on top you'll get 2 times 20. You still have the sign plus, so you add the following result. 3 and crisscross 15 goes as the extra factor. So that's why it's going to be 3 times 15. So that's pretty straightforward way. Don't forget to multiply denominators, 15 times 20. And on top, just crisscross allocate 20 to 2 and 15 to 3. And multiply them out and then add the result. So that's an idea. And if you work it out, you'll get the following. So 2 and 20 is going to be 40 and 45 here. So 85. Okay. In the bottom part, you'll get 15 and 20. And now it's time for canceling. So 85, if you divide by 5, right, you can even cancel, you'll get 17. So that's why your fraction after that, after simplification, if you cancel by 5, it's going to be 17 over. So because we canceled by 5 everything, so I just cross out using, let's say, green one. So I cross out 85, let's say 15. So here is going to be 17 left, and 15 has 3 left. And 3 times 20 is going to be 60. So that's why the final result is going to be 70 over 60. But I'm going to show you a bit different way using the lowest common denominator, or LCD. So if we use LCD, so using LCD concept. What does it mean LCD? LCD for 15 and 20 is the lowest common multiple. So that's why we take in 15 and decompose as 3 times 5, right? So if we take 20, we can decompose as 4 times 5. Okay, so 4 and 5. So that's the product. So in LCD, in this case, we will include 3 and 4 because they're unique for each number, 3 and 4. And on top of that, we will include 5 only one time. Okay, so that's how LCD is calculated. So this is an idea of LCM, the lowest common multiple. Okay, and now we've got the following. So 3, 4, and 5. If you like, you can multiply, you'll get 60, but I don't recommend to multiply. And first, what I'm going to do, I just show workings here. So I'll show you how to use LCD concept. So LCD is simply 3 times 4 times 5, okay? So that's why what I'm going to do, I'm just going to say that the LCD is 3 times 4 times 5, okay? Or if you like, you can put 60, but for some cases it's highly recommended to leave as the multiplication of numbers in order to cancel on the later stage. Okay, so for the first numerator, which is 2, how to find the extra factor is similar to what we're doing here. It's not just 20 right now, because using the idea of LCD, we need to divide the LCD by the fraction, by the denominator in the first fraction. So we divide in 60 by 15, and we'll get 4, and that's the extra factor. Okay, because 60 we divided by 15, so that's why how 4 goes there. So 4 goes there in this case. So what about the extra factor to 3? We need to divide 60 by 20 now, and we know it's 3. Okay, so that's why 3 times 3, that's the second part of the fraction. And if you calculate, you'll get 2 times 4 is 8, and plus 9 is going to be 17 on top, and over 60. You know, the first way is pretty straightforward. We got the same results. But in some cases, when you work with bigger number, not like this small one, but with a big one, so please try to get acquainted with the concept of LCD and the lowest common multiple. Okay. But in case of small numbers, I recommend to use the first way, the first approach. How to simply do that, multiplying denominators and crisscross allocating the denominators as extra factors. Okay, so make sure you will use this way. So this is more simple way and an easy way. All right, so next one, subtract 4,318 from 5. So subtract this amount from another amount. Okay, so that's why we're starting from this 5,152. Okay, and we take it away. So in this case, we can use the column methods. 4,318. Okay, so let's try to do this. 2 is less than 8, so that we grab 1 point from there. And now, let's do. Okay, so, sorry. We grab that, okay, grab unit from 5, and we take away, so from 12, 18, 8. So it's going to be 4, okay, 4 in the end. Now we have 4 instead of 5, because we grab 1 unit from that, from tens. So that's why it's 4 minus 1, that's 3. We grab again from next one, from next digit 5, we grab 1, and we take away from 11, 3. Okay, so 11 minus 3 is 8, and we have nothing here for the thousands. So that's why the final answer is 834. In this case, I recommend to use the column methods because it works easier than doing it mentally. Okay, that was problem number 4. So next one, Joe made 3 purchases for, okay, their amounts of purchases. How much did he spend in total to nearest pound? Okay, so first you're calculating the total result and then round it up to the nearest pound. Okay, so let's do that. So in total, we need to add those amounts. If you like, you can calculate and work out the result in pences, okay, and then you need to divide by 100. So calculate result in pences and then divide by 100. So 412 plus 1220, okay, and plus 370. That's the amount that you need to add them up, okay? So you can do it, I think, mentally, and let's first do that. So 412 plus 1220 and 370 is going to be 15 and 19. Okay, so now you add in, it's up to you guys, but if you like, you can use the call methods. So it's going to be 2, 0, 0, and 2. So the total result, if you add all those numbers, and you don't need to forget to divide by 100 because your result right now in pences, so you've got 27002, but now you need to divide by 100 because right now you have pences. So if you divide by 100, you'll get 20.02 in pounds, and that's your final result. For those who can work with the triple summation, so you can use the call method for all of 3, so like this. Okay, let's say for 12, no matter which like order you set up the numbers, but I prefer the decreasing order, so that's why I first allocate the greatest amount. Okay, so you do the same, 2, 1, and 3, so 0 here, 2, 4, and 3, it's going to be 6 and 3, and 0, and 1 from there. Okay, so that's why it's 1. Sorry, it's 0 and 1, you add 1, so that's why it's 2. So that works pretty fast if you make sure, so if you're confident with that, just make sure you use this method. All right, so that was pretty easy. And now comparison. Okay, so you have different numbers and you need to compare them and set up in increasing order. So it means start from the smallest one. So start from the smallest. Okay. If you start from the smallest, how to compare? Okay, so let's have a look. First, you need to compare their whole numbers. They are all the same. There is nothing to compare. So using, oh, by the way, sorry, I just forgot about the rounding. Yes, to the nearest pound, of course, we need to round up, and the final result is 20 pounds to the nearest pound. Sorry, I just forgot this. Okay, so that's the final result to the nearest pound. Okay, that's rounding process. I hope you understand how it works. You just cut off there, and you see that decimal point and the digit after decimal point is less than 5. So that's why there is no effect in rounding. So that's why finally you will left with 20 pounds. Okay, with 20 pounds. So that's the final result to the nearest pound. Okay, so coming back there. Now you go on and trying to compare the next digit after decimal point. So here's 3, here's 3, here's 3, here is 1, okay, and here's 0. Of course, that goes first, right? No matter what stays after. So the second digit, basically tens, so tenses, this number has the lowest 0 tenses. So what about that? This is 1, so that's why this is the first, that's going to be the second. And we're left with a group of 3, and we need to continue the process of comparison. Now I choose another color, and let's compare the next digit. So 2, 2, and 0, okay? And in hundreds, yes, we have 2, 2, and here is 0, so that's why that's definitely smaller. So that goes the third one, okay? First, second, third, and we just go to next. Here, there is nothing to compare, but I use green. There is nothing to compare, that means 0 stays there, okay? So this number you can write as 5, 3, 2, and if nothing goes after 2, you just simply put 0 in the end, because we need to compare digits. If there is missed digits, so obviously we need to put 0. Okay, while here is 1. So that's why if you write this, you'll need to write 321, and that's definitely greater than 0. So that goes on the first place, and that's on the fifth. And now you write them in the order, but I'm not going to write, so I just mark them, okay, how they goes. So first, second, third, fourth, and fifth. All right, let's move next. 7, write the following as an equivalent fraction. So one more time, the equivalent fraction, as the simplest form of the fraction, that's equivalent to yours, okay? So 48 and over 62. How we can do that? We can actually say that we have 48 over 64, and we can write as, we again represented the top and the bottom by using the factors as the product of factors, so that's why it's going to be 6 times 8, okay, and you know that 64 is 8 times 8, okay, so obviously we'll get 8 cancel and we're left with 6 over 8, but this is still not the equivalent in simplest form, so that's why we need to simplify even more. Actually, on top of that, you need to perform your equivalent fraction in the simplest form. So that's why 6 over 8, that's going to be the simplest form of that. If you cancel, it's going to be 3 over 4. So if you are not told to give the answer in the simplest form, so I recommend to leave in the simplest form. So because 6 over 8 is also an equivalent, but not in the simplest form. So this is simply the simplest form. And I recommend to leave your answer in this case, even if you're not told like in this problem. Okay, so next, 36 over 120. What we can do, so 36 is simply 9 times 4, while 120 is 30 times 4, okay? Now 4 can be cancelled. You're left with 9 over 30, and you can cancel even more because you obviously know that's 9 is 3 times 3, and 30 is 3 times 10. So that's why you'll get 3 over 10 as the final result. Okay, so that's how canceling works. Let's go next. Here is the problem about numbers. I think of a 2-digit number. So what does it mean 2-digit? It means like XY. Let's say 29, for example, 38, and something like this. Okay, up to 99. So that's the last digit. This is the maximum 2-digit number that you might have. Okay, so this 2-digit number is the multiple of both 3 and 7. Okay, so that's the first condition. So that's why you're thinking about multiples of 3 and 7. And it also needs to contain 4 units. So that's why you definitely know about y. So your y actually, because that tens and that units, your y equals to 4. So you already know that y is 4. So that's why you're looking for the form of x something, and 4, this is your 2-digit number. Okay, now you're looking for multiples of both. So what does it mean, the multiple? So multiple of 3 and 7. It's something that the number that can be divisible by 3 and 7 together. So the first is the product 3 by 7 because they're both primes. So both primes, so that's why to calculate the multiple is simply multiplying 3 and 7. So 3 times 7 is 21, okay? That's the first multiple. The next multiple is going to be 2 times more, let's say 4 times more, and so on. Okay, so that means if you multiply it by 2, you'll get 42. That's the next multiple. So we have the first multiple, which is 21. It will multiply by 2, we'll get 42. And one more time, if we multiply by 2, we'll get 84. And that's what we're expected to have, because our result should end up on 4. And this is the right form. And this is two-digit number. So that's why in our case, so x equals 8 and y equals 4. That's two-digit number. So final result is 84. And this is your two-digit number. All right, so let's move next. Find 3 consecutive numbers with the sum of 36. All right, so the sum of 36. What does mean consecutive numbers? Numbers that three, I think they need to mention that it's going to be actually integers. Obviously, your numbers should be integers. We're not doing something hard with decimals or with fractional numbers. So your numbers are integers and they should be positive integers. So on top of that, I'm going to say that's positives. Otherwise, the sum of 36 can be arranged. Okay, so how to work with that? Let's say your first number. So I'll show you the idea of consecutive numbers. Let's say starting from 2, that's your first number, the second is 3, the third one is 4. So every next number is one more than the previous one, okay? That what means consecutive. They're consecutive integers. Okay, you can pick up, or you can, you can work it numerically. So if you work it numerically, let's say your first number is x. The second one is one more, so that's why it's x plus 1. And the third one is simply x plus 2, obviously, right? For example, if you plug instead of x 5, you'll get 5. Here is going to be 6, and here is going to be 7. That's your example. However, in our case, if you add them up, that's definitely not. So it's better to arrange their equations. So if you add them up like this, that's the first one, this is the second one, and this is the third, you should get the sum of 36. And now you need to solve for x. So just solve for x. That's the first way how you can do that. So the way of equations. All right, so you'll get 3x because you add in x's together, 1x, 2x, and 3x. So 3x in total. And you also add 1 and 2, you'll get 3. And the result is 36. Then you take away 3 from both parts, and you'll get 3x equals 33, from where you'll get x equals 11. So the first number is 11, okay? And that's why the next one is 12 and 13. So your numbers are 11, 12, and 13. You can check just by adding them. The second way, how you can try to solve. So you can start, because the numbers are pretty close to each other, you can try to divide 36 by 3. And that's going to be your starting number. Because numbers are pretty like the same. Just one is the difference. So that's why you can try to say that if they're, let's assume they're identical. So 36 you divide by 3. You'll get the number which is 12. And if 12 is the starting point, so you can try like 12, 13, 14. If you add them up, you'll get 39. So the sum is going to be too much because it's 39. So that's why your starting number should be one less. So next trial is you take away 1. So 12 minus 1 is going to be 11. That's your starting number. So that's why you'll get 11, 12, 13. And this is exactly what we've got using the equation methods. So that's how we can work out using trials and errors approach. Okay. So next one, we have 210 when multiplied together. So what it means? It means that it would take the numbers, 3 consecutive numbers, like as we set up, we take an x, we multiply by the next one, which is x plus 1, and we multiply by the x plus 2, so that we need to get 210. What I recommend, of course, you cannot solve this equation because it's pretty hard for 11 plus, that's cubic equation, but the idea is pretty obvious. So if you start like expanding, you'll get somewhere around x cubed. So you'll get a round cubic number. So that's why you might use this observation in order to say that, okay, some number in cube should give me around 210. Okay, so which cube numbers you know that gives you 210 or around it? So that's why you need to try. Now try to pick up some numbers. Try to pick up some numbers. Okay? So that the cube will be around 210. Okay? That's an idea. So for example, if you start from, let's say 5, because you know that 5 times 5 times 5 will give you 125, right? So if your starting point is 5, so 5 cubed, that means 5 times itself will give you 125, yes? So that's definitely twice less, around twice less. So that's why the next trial is 6. So 6 cubed. It means 6 times 6 times 6, okay? In this case, you'll get 216. So if you multiply them, you'll get 216. Okay, so that means it's too much. So that's why your numbers should start from somewhere 5 or 4. Okay, from 5 or 4. Let's try to pick up. If you start in numbers 4, so the next one is 5 and the last one is 6. If you start multiplying them, you'll get 4 times 5, which is 20, and 20 times 6 is 120. So the product, if you multiply them, the product will be too low. It's 120. So that's why you start from 5 now and start thinking, okay, if I start multiplying 5 by 6, you'll get 30, and then by 7 you'll get exactly 210. So that's why your lucky combination is this one. So your lucky numbers are 5, 6, and 7. So that's the method of trial and errors, but you cannot, again, I just put a stress that you cannot pick up like different random numbers. You need to have some starting point, and this starting point was created using the cubic number. Okay, that approach will help you, but you can also try to make a scientific guess starting from some random number and say, okay, if it's really too far, like you start from 2, for example, it's really too far, like 2 times 3 times 4, it's definitely too far. So you increase like by 1, by 2, and then repeating your procedure. That's again using trial and errors method. Okay. So number 10, equations. Okay. How to solve equations. So the first one, you'll get 18 times 3x and you divide by 27. So I recommend to use the fractions. Okay, so the brackets, what's inside the brackets, you divide by 27, so represent as fraction. You know why? Because right now 3 and 27 will be cancelled. So that means you can get 18 times 3x and over, sorry, why 3x? Times x, so 18x, and over 27 is 3 times 9, so it's 9. Okay, it's 20. Now 18 over 9 is gonna be cancelled as well. So it's gonna be 2. So 2x is 20. So that's why x is 10. You see the power of canceling the fraction first. What if you start using, okay, first I'm gonna find the value in the brackets. 18 times 3x is 20 times 27. Wow, it's quite a big number. While canceling allows you to work with, simpler numbers and smaller numbers, okay? Trust me, this way is pretty good, okay? Of course, you can check if you like. So you can plug back. If you have time in exams, you can check by plugging back and trying to make sure that the left side and the right side will give the same result, okay? So that's an idea. So next one, we first, here, what we're gonna do, I think we adding 3 to both parts. So adding 3 to both parts, because we have -3, or, if you're just addicted to the way you transfer -3, that also works. And we also 65 minus 3, yeah, that's cool. I'm not going to expand the brackets, so x minus 10 times 2 is going to be 62. Sorry, my bad. 68. Yes, we add in 3 to both parts. Then we divide in everything by 2. Because you can kill 2 here, and 68 over 2 will be also simplified. So that's why you're left with x minus 10, and on the right side 68 over 2 is going to be 34. Okay, so from where x is 44, because it transferred -2 to the right side. Okay, or you add in 10 to both sides if you like. Okay, so that's the result here. Okay, and that one, it's all about expansion. Now here you need to expand the brackets, so remember 2 goes there and 2 times -1. Okay, so that's why it's going to be 4x minus 2. And now you see that -3 should go here and should go there. So that's why we left with -3x. And when -3 times -1, you'll get +3. So that's why you'll get +3 in the end. Okay, make sure you remember. Nice. Okay, so now we're looking for similar terms. We've got 4x minus 3x, which is just 1x. And -2 and +3 is going to be like 3 minus 2 is 1. So 1 transfer here to the right side is going to be 6 minus 1. Okay, 6 minus 1, which is 5. So x is 5. Again, so you can check yourself by plugging the final answer into what you have here, okay, into your equation, and just check that it's all correct. Okay, so this one, 18 over x is going to be 3 over 2. So this is the fractional equation. And just remember the idea of equivalent fraction. If you use equivalent fractions, you just simply need to say what should be instead of x, so that 18 and over x will give you 3 over 2. So that's the brilliant idea, how to solve that with not knowing what sort of equation is this. So 18 is simply 3 by 6 over something, should give you 3 over 2. So that means 6 and x should be cancelled, so that instead of x, that's going to be 2 left. Okay, so it should give you 3 over 2. So that means 6 and x should be cancelled, so that 6 completely is gone from the top, and x, instead of x, that's going to be 2 left. So obviously it's 12. So instead of x, that's 12, because 3 times 6 over 12 will give you the result 3 over 2, because 6 and 12 will be cancelled, okay? So that's why x is 12. So that's the first way how you can think of this sort of questions and problems. But I'll show you another way. So that was way 1. And way 2, how you can work with those sort of equations. So 18 over x equals 3 over 2. That's more about mechanical way of doing. And what you need to remember, you can swap any number that stays on top and in the bottom fraction crisscross. So for example, you want to stay final with x equals something, right? So you want to stay that with x equals something, okay? So how you can do this? You can swap x and 3. So what does mean swap? It means that you set up x here while 3 goes down, okay? So that's why after the first iterations, you'll get this following, okay? I'll just swap that. Okay, you'll get the following. So that's after the first. Swapping 18 over 3 will give you x over 2. And now you want to live with x on the right side. So that's why you again swapping. But in this case, you're not going to swap. You just put 2 here. Okay? So crisscross. And they always appear as the factors. So not addition, but factors. So this is the mechanical way. Or mnemonic way, let's say. 18 times 2 and over 3. So that's going to be 18 times 2 and over 3 equals to the x. So from there, you can say that 18 over 3 is 6 and 6 by 2 is 12. So x is 12. So this is an alternative way how you can do. But if you're pretty confident with equivalent fraction, just go using that. Because it's pretty more clear. That might be new for you. Okay. And the last one. So write down the next 2 terms for the following sequences. So what does mean sequences? Sequences just arrange pattern where some specific rule exists. For example, you know the rule by knowing how you can get the next term. So the term here is each element of that sequence. So this is the first term, this is the second, this is the third. And you need to find 2 other missed terms. Okay, so you're starting from 8, and the general idea, you're looking for the pattern. Okay, how to write from 8 to 12. So obviously, if you use addition, so you can add 4, right? How to come from 12 to 16, you again add in 4. So that's why the rule here, so the rule in the first one, every time add 4, so add 4 to the previous term or to the previous element. Okay, so that's why you can simply fill up with no problem. So this is going to be 20 and that's going to be 24 because every time you add in 4. Okay, so let's move next. 2, 4, and 8. So if you try to use addition, for example, I'll show you separately here. So 2, 4, 8. If you try to use addition, you need to add 2 here, while here you need to add 4. Maybe that will form you the pattern. So this idea will form the right pattern. So next time, obviously, you need to add not 4, but 6, right? Every time 2 more, and you'll get 14. But I don't recommend to do that because this might be the case. Here is a bit, here is this example is really ambiguous. So it means they might be using that rule or they might be using a different rule. So what do you think about and normally how you should solve, because I've seen this similar to in Sevenoaks past papers. So you're thinking about multiplication. If you multiply by 2, there is no doubt that you'll arrive to 4, as well as you multiply by 2 and no doubt you'll get 8. So that's why next time if you multiply by 2 you'll get 16. And as you noticed before, using addition, we arrived to 14. So that's what I'm saying. Depending on how you look at this pattern, you will find out different solutions to that. And actually, who accomplished this paper and similar, because I've seen that in past papers for Sevenoaks, they need to mention one more term in this case in order to, exclude those ambiguity. Okay, so that the solution should be a single one. Okay, so I recommend to choose the pattern that used multiplication. So that's why next term, every time, the rule here is every time times 2 the previous term. That's how the rule for this sequence sounds like, okay, the previous term. So that's why the next term is going to be 8 times 2, which is 16. And again, times 2 is going to be 32. Those missed terms. Okay, the next pattern. 1, 4, 9. 1, 4, 9. All right. If you try to add, there is nothing happened. If you try to multiply, there is the same story. But remember, I told you that we can numerate those elements. Like this is the first, this is the second, and 9 is the last one. So if we do that, we can say that, okay, this is the first term, this is the second, this is the third. Okay, so this is numeration of terms. The first one, first, second, third. So obviously it's going to be fourth element and fifth element. Okay, and what I notice here, that they are actually square numbers. Square numbers. What does mean square numbers? The number that looks like a perfect square of another number. So that, for example, 1 is just 1 squared. So 4 is just 2 squared. 9 is just 3 squared. Okay? 3 times 3, 2 times 2, and 1 times 1. So obviously the next fourth term, and if you have a look to the patterns, to numeration, you'll understand that because it's first number, so we raise 1 to the square. That's how we can get the value of the element 1. So what about the 2? The second number, we raised again to the square, and that's how we get 4. So 3 squared will get 9. So obviously 4 squared is going to be 16. And 5 squared is going to be 25. So we just simply enumerate the square numbers. So that's why the missed numbers are 16 and 25. And the rule here, if you want to write the rule here is to say that the consecutive square numbers, the consecutive square numbers. Okay, and just for extra, I'll show you what about cubic sequence. So let's consider the sequence. So cubic sequence, for example, that doesn't refer to that. This is like separate my extra example. So 1, let's say 8, and let's say so 1 cube, 2 cube, and obviously 3 cube is going to be 27. So if you're given this one and you need to write missing other terms, obviously you understand that each number is a cube number. So that's going to be 4 cube, which is going to be 64, I guess, right? 4 times 4 is 16, 16 times 4. Yeah, 16 times 4 is 64. And the last one is going to be 5 cube, which is 125. If you want to see that pattern, that's definitely cube numbers. The rule here is consecutive cube numbers. Okay? So guys, hope you like that. If you're new here, don't forget to subscribe. I'll think I'll prepared the next episode for test 1, so that's going to be more about word problems, a bit of geometry. Don't forget to subscribe, don't forget to smash notification bell button in order to be notified, and also just get to know that my channel enriched by GCSE program as well and A-level. That's for your first education, so you can grab very interesting things from there. If you're still kids like 11 plus, maybe 10, so that will be informative for you, definitely, for sure. So subscribe now in order to be tuned up for a long perspective. That was Daniel Dallas, and see you next time.